3.6, divisibility and prime factorization. First point here about factors, a little star. A number is divisible by another number if the number divided by the second number leaves no remainder. Oh, we're going to have no remainders. Isn't that so nice?
Yes.
Okay.
Right there.
So, a number divisible by another number, if you get no remainder, we call that a factor. Okay. So no remainders. When you divide something, no remainders. So, for example, 6 divided by 1. If you take 6 divided by 1, what do you get?
7.
You get 6. Is there a remainder?
Yes.
No. So 1 would be a factor of 6.
Yep.
6 divided by 2.
3.
3. Is there a remainder?
No.
No. So 2 would be a factor of 6. 6 divided by 3.
2.
2. Is there a remainder?
No.
No. So 3 is a factor of 6. 6 divided by 4. 6 divided by 4. Quick, Jake, on the calculator. Go.
Could I have a remainder? 1.5.
1.5. Is there a decimal is the same thing as remainder? Is there a decimal remainder? So this one, not a factor. 6 divided by 5.
1.2.
1.2. Is there a decimal / remainder? Not a factor. 6 divided by 6. 1. So what do you notice about these? 6 divided by 1 equals 6, and 6 divided by 6 equals 1. Right? These numbers, so 1 is a factor, 6 is a factor. 2 is a factor, 3 is a factor.
Oh!
Okay? That's what a factor is. So if I give you another number of 20, well, that's not a 20, that's a big one. Let's give it number 4. What are the factors of 4? What fits into 4 evenly?
2.
So 4 divided by 2 fits in there 2 times. So 2 is a factor. 4 divided by 1 equals 4.
4 divided by 4.
4 divided by 4 equals 1. So 1, 2, and 4 are all factors of 4. That's finding factors. Okay? All right. Here's some divisibility rules. These are helpful for knowing if something is a factor of something else. So, the rule for 2. If the number is even. A number is divisible by 2 if it is even. So, 2, 4, 6, 8, 10, 12, 262, that's an even number, right? 265 is not an even number. The number is divisible by 3 if the sum of its digits is divisible by 3. For example, 204. What's 2 plus 0 plus 4?
5, 4,
6. 2 plus 0 plus 4.
Is 6 divisible by 3? So then 204 is divisible by 3.
Wait. Slow down. Slow down. I'm gonna write this down.
So because 6 is divisible by 3, and when you add all the digits up, 2 plus 0 plus 4, it equals 6. Then we know that 204 is also divisible by 3. If the number is divisible by 4, the number in the last 2 digits, if that is divisible by 4, then your number has 4 as a factor. So 4,852, what are the last 2 digits?
52.
52. Is 52 divisible by 4?
No. Yeah.
Yes. 5 plus 2
It
plus
is.
6. And 6.
No, we're not doing any adding here. We're just looking at 52.
No, it's 52 divided by 13 or 14. One of those two.
14.
14.
So 52 divided by 4 equals 14. So that means 4 is a factor. Oh, sorry, not 14, 13. I did my math wrong. 13. 52 divided by 4 is 13. So that's our 4. 4 is a little harder than the other one so far. 5 is another easy one. 5. If the last digit is a 5 or 0. So if the last number is a 5 or 0, 5 fits in evenly. The number 6. So if the number is even and is divisible by 3. So it fits the rules for 2s and 3s, then it will be divisible by 6.
Can you just do like the factors though? Can you just do that way instead of memorizing all this?
Yeah, but if I gave you the number 4,852 and said list all the factors, it'd take you a while, right? So it's kind of nice to know the shortcuts.
But for the lower numbers, can you do this?
You could, yeah. The lower numbers are easier, right? You don't need to think about it as much.
Okay.
Number 7, there's really not a good rule for number 7. Sorry. You just kind of have to do it. Number 8 is very similar to the 4 rule, but this time it's if the last 3 digits are divisible by 8. So if the last 3 digits are divisible by 8, so an example, off the top of my head, 856. Well, I can make a bigger number than that. I could say like 56,856. The last 3 numbers are 8, 5, and 6.
And we can divide 8 by 8.
You can divide 8 by 8 and 56 by 8.
6 by 8.
So that works then.
Should be 17.
So it's like 100 and
70.
divided by 8 is
70.
107.
Oh.
Okay, so it fits. 9s. This is very similar to the 3s, but if the sum of its digits are divisible by 9. So for example, let's do an example here. Make that an example. 342. 3 plus 4 plus 2 equals 9. Does 9 fit into 9 evenly?
Yeah.
Yes, so that means 342 is divisible by 9.
Why?
Your 10 rule, that one is one you should know. What does a 10 have to end with to be divisible by 10? A 0. Okay, let's try a couple here. So, this is what we're going to do. We're going to put the numbers here. 2, 3, 4, 5, 6. We're going to skip over 7 because I don't have a rule for that. 8, 9, and 10. We're going to cross them off if they don't work. 4,320. So let's look at our 2 rule.
Yes.
Is it even?
Yeah.
Yes, so 2 works. I'll put a little green check by 2. That works. 3 rule. What's the 3 rule?
You have to. If the sum of the digit is.
Okay, so add up the digits. So 4 plus 3 plus 2.
7, 9.
9. Is 9 divisible by 3?
Yes.
Yes, so 3 works. The 4 rule.
If the last two digits are divisible. And it
So the
is.
last 2 digits are 20. Does 4 fit into 20 evenly?
Yeah.
Yep.
Yes. 5 rule is an easy one. Has to end in a,
0 or 5.
ends in a 0. 6. What I look at is does the 2 rule work and the 3 rule work?
Yes.
Yeah.
Yes, then 6 is good. We'll skip over 8 for now. That's probably the hardest one there. 9 rule.
Yes.
Yes. Yeah.
4 plus 3 plus 2. 10 rule.
Yes.
Okay. 8 rule. Let's go back to that one. We say yes on that one. So we're looking at 320. Does 8 fit into 320?
Yeah, because 32 fits into 8.
So 32 fits into 8, so then 320. Mhm.
All of them fit.
All of those ones fit,
Except 7.
except we don't really care about 7 right now. Okay. All right, let's look at our next number. So 845. So we're going to go 2, 3, 4, 5, 6, 8, 9, 10. Do the easy ones first. Is it an even number?
Yes. No.
It's not an even number, so 2 doesn't work. What about 5s? Do 5s work?
Yes.
No.
No.
Yes.
Ends in a 5. What about 10s?
No.
No.
10s don't work. Okay, now let's get to a little harder ones. Number 3. So 8 plus 4 plus 5.
12. 17.
17.
No.
Does 3 fit into 17? No. 4s. Does 4 fit into 45?
Yes.
No, it doesn't.
Evenly?
No.
Not evenly.
Oh no.
Fits in, but not evenly.
6 doesn't because 2 and 3 don't.
6 doesn't because 2 and 3 don't. Good. 8. 845.
Yes. Yes.
Miss that, waiting. How many times does it fit in there?
Well, because 45 fits. And
No,
Does
No,
it-
it wouldn't.
no, 8 times 5 is 40.
Oh, right. So it doesn't.
Yep, so it doesn't work. Do you guys see what they're doing in their head? They're doing this in their head. They're going, it fits into 800 evenly, right? 8 fits into 800. Does it fit into 45 evenly? No, it doesn't. So that one doesn't work. 9s.
No, it wouldn't work.
If it doesn't work for 3, it's not going to work for 9.
5.
Only 5.
It only works for 5. 2, 3, 4, 5, 6, 8, 9, and 10. All right, the number is 162.
Yes.
2, it's an even number. What about 5?
Yes.
No.
Oh, no.
No. What about 10?
No.
No. Okay, what about 3?
Yes.
6 plus 2 plus 1 is?
9. Yeah, it works.
9. So what about 6 then?
It works. Yes.
Yes.
Works for 2 and 3, it's going to work for 6.
And 9.
And 9. Okay, so we just got 4 and 8 to do. 62.
No.
Nope.
Okay. I heard some pretty quick no's. This is how my brain thinks about it. I break 62. I know 4 fits into 40,
But it can't. Yes.
right? And then there's 22 left to get to 62. So does 4 fit into 22 evenly?
No.
No. So then that's how my brain works on it. Maybe you have got a different trick that you do. 8s.
No.
No.
Does 8 fits into 80, right? Evenly. And 2 80s is 160.
Yeah.
Yeah, so it doesn't fit.
So it doesn't fit in 162. It has to be 168 probably. That's where my brain goes on those. Now, yours might go a little different. You might have to write some things out. So those are divisibility rules.
Cool.
Shortcuts to help us with some things. Now we're going to talk about what a prime number is, what a composite number is.
I still have that chart from last year.
A prime number is a number that is only divisible by 1 and itself. And they go on for a really long ways, but some that are really easy to remember are the number 2, 3, 5, 7, 11, 13, 17, 19. We keep going, right? 20, is that? Nope, that's an even number. 21, nope, that fits into 3.
2's an even number.
23. Yeah, but only itself and 1. So, right, 2 fits in there and 1 fits in there. So it's itself and 1. Well, let's list a couple more numbers here. No big deal. Don't feel like you need to memorize all these numbers. And they just like go on forever. These prime numbers. It's just a list. it goes on and on forever.
Mr. Alzheimer, you can do that.
So when you think about this,
27.
27 is divisible by 3, right? Because 7 plus 2 is,
But it's an odd number.
it's an odd number, but odd numbers can be
But we also skipped 33.
And 9.
in 21 and 9 and 15.
And 95.
So just because it's odd doesn't mean, so no even numbers are prime, right? Because every even number is divisible by 2, right? So every even number is not prime. So it has to be an odd number, unless it's 2. So the only even number that is prime is 2. Every odd number, we're not sure. We've got to decide if 3 or 4 or 9 go in there if it's an odd number. Okay?
Keep going.
So let me give you another number here. Let's pick the number 73. Is that prime or not prime?
7 plus 3 is 10.
Okay, so 9 doesn't fit in and 3 doesn't fit in. What about 4?
No.
4. 4 is not fitting.
So try to figure out, is 73 a prime number? Does 1 fit in there? Yes. Does 2 fit in there?
No.
No. How about 3?
No.
No. 4?
Yes.
We're not sure yet. 5?
No.
6?
No.
No, because 2 didn't. 7? That's a hard one. 7 into 73?
No.
No. 8? We're not sure yet. 9?
No.
No. 10?
No.
Okay, so we got to figure out 4 and 8. See if they fit in there.
4 is
We're trying to figure out what number.
73.
Oh.
73.
Is on here?
Divided by 4. No, 4 doesn't work.
4 doesn't work? Okay. What about 8 then?
8.
8 doesn't.
Last 8 should it doesn't work.
8 shouldn't, right? Because 72 8 fits into, because 8 times 9. So, and then you got to think a little bit more. 11, 12, like there's more numbers there that could fit in there. But if you eliminate those first numbers 2 through 10, that gets you a big start on that. All right, a composite number is a whole number. That means no decimals. No decimals. And it's a whole number that has no decimals, and it has to have more than 3 factors. Because every number has the factor 1 in itself, right?
Right.
So if it's got a third factor. So a composite number is any number that's not prime. So 12. What are the factors of 12?
6.
1 fits in there.
2.
3.
2 fits in there.
2.
3, 4, 6, and 12. So are there more than 2 or more than 3 factors?
It's composite. Take me forever.
So it's a composite. What about 7? What are the factors? 1 and 7. So we said it's a prime number, so it can't be composite. So this one is composite, and this one is prime.
Wait. So if any of the numbers have one of those numbers up there, then it's a prime number?
If the number is 2, 3, 5, 7, any of these numbers here, it's prime. These are all prime numbers. There are
Then
more.
you don't have to do the math.
There are more. Then the only 2 things that fit in there, Ethan, are 1 in itself. There are more of them. There are more numbers that are prime. Okay? All right. I know you guys did some of this last year.
Yeah.
Prime factorization. You used factor trees. Remember that?
Oh yeah.
Wait, is it like the where you go this one, circle that one,
Is it snowing?
go off that one, circle that one, go off that one. Like, so it's like food, and
Yep.
go off this one, and go
Yep.
off that thing. And you get the answer out of all the ones. Yeah. I get that.
So what we're going to use here, we're going to use a factor tree to break a composite number into prime numbers.
Wait, so Mr. Elsinga, you're not a prime
Not this year.
Are you sad about that?
No.
You just see.
I'll just teach whatever I want. Only math this year.
No
And
Bible.
Bible,
No
right?
Bible this year.
Really? What?
Who teaches Bible?
Miss Demeester's teaching it.
Really?
So you only teach math?
Classes?
Well,
Well, in sixth
two
grade.
6th grade math and two 7th grade math.
Yeah.
And then what do you do the rest of the day?
Naps.
He's the head, like,
Oh,
Take naps. Make sure you don't get into trouble. I'm looking at you, Ethan.
Yeah.
Stocks in your.
All right.
yeah.
So you were going to use these factor trees. And this is where you took underneath here and you said, all right, what two numbers fit into here? Oh.
101.
So I would look at this and I'd think, it's an even number, so I know 2 fits in there, right?
Where you find out the other number.
So 154 divided by 2. This is where I'd use a calculator because I'm that kind of person. I'll just tell you it's 77, but you guys get your calculator out so you can keep working on the 50.
77.
77. What fits into 77? Does anything?
11.
11 does. 11 times what?
7.
7. Okay. Do we have prime numbers here?
Yes.
2 is a prime number, 7 is a prime number, and 11 is. I always like to circle my prime numbers so I know I'm done with them.
I like this. It's so easy.
So that's a factor tree. Now let's make it what we call prime factorization.
Do we just stop there then?
So that's 2 times 7 times 11. That is prime factorization. So if you type 2 times 7 times 11 in your calculator,
2 times.
you should get 154.
Yep.
Yep.
Nope.
Error status.
Then you push something wrong.
Yeah, 154.
All right, let's look at the number 63. What fits into 63? This is where it's helpful to know your division things. Otherwise, you're going to be trying a lot of numbers. 6 plus 3 is 9, so we know 3 fits in there. 3 is also a prime number, so I'll circle it. 3 times what equals 63?
21.
21. 21. What fits into there?
8. No, 7.
7 and 3.
7 and 3, which are both prime numbers. Now, this is 3 times 3 times 7, but we have a shorter way to write that. Do you remember how you write?
3 to the third power.
Not to the third.
To the second power.
Yeah, 3 to the second power times 7. Because you have 2 3s there.
Equals 63.
Now, did anyone do that one? You could probably do that one differently also. Let's look at the next number, 630. What fits in there?
9.
10.
9 fits in. Let's start with that. 9 times what?
20.
You can go by tens, John. Go by tens.
Just go by nines because that's what he's writing.
What fits? 9 times what equals?
70.
9 times 70?
26.
Are either of those prime?
No.
Nope.
No. 9. No.
9. What fits into 9?
3.
3.
3 times 3. Those are both prime. What about 70?
10 and 7.
10 and
Wait,
7.
What? How,
10 is not. 7 is prime. So 2 and 5.
No. And then they're both prime. So then you do 3 to the second power times
So,
7.
when you write your prime factorization, write the smallest number first.
Oh.
So 2 times 3 times 3 times 5 times 7. I can write it shorter where you're going 2 times 3 squared times 5 times 7.